Welcome to the Explainer. Today we're going to talk about smart devices. What actually makes them smart? We're going to pull back the curtain on that so-called magic. We'll break down the basic hardware that powers, everything in the Internet of Things. Think your fitness tracker, your smart fridge, all of it. So let's start with a really simple question. How does a smart thermostat know when to turn on the heat? I mean, it seems like magic, right? Like it's just thinking for itself. But what's actually going on under the hood is this super simple, really elegant continuous loop. And it's a process that every, and I mean every smart device follows. Okay, so here it is, the simple loop of smart. It's just 3 steps. Sense the world, think about the data, and then act on the decision. Sense, think, act. That's it. These 3 things are the secret sauce, the fundamental building blocks behind any device we call smart. So let's kick things off with that very first step, how a device gathers information from the world around it. All right, part 1, sensing the physical world. This is where it all begins. It's all about how a device, perceives its surroundings. It uses its own little set of senses to just gather up all that raw info from the physical world. So what is a sensor, really? Well, you can think of it as a bridge between our physical world and the digital world. They're basically the eyes, the ears, even the skin of an IoT device. Their whole job is to take real-world stuff like heat or light or motion and translate it into an electrical signal. Why? Because that signal is a language a computer can actually understand. And it's not just one type of sense, right? The variety here is just incredible. We're talking about way more than just temperature. These things can sense motion in a room, they can sense how bright or dark it is, the pressure in a tire, heck, even specific gases in the air. Each one of these sensors gives the device a different piece of the puzzle about what's going on around it. So let's go back to our smart thermostat example. Obviously, a temperature sensor, something like a thermistor, is going to be the star of the show. That's a given. But you could also toss in a motion sensor. Why? Well, it could detect if someone is actually home, which lets the device make an even smarter decision about when to kick on the heat. See how that works? Okay, here's a really important detail. The sensor creates that electrical signal, right? But a lot of the time, it's an analog signal. Think of it like a smooth, continuous wave of information. The problem is, the device's brain only speaks digital. That's the language of ones and zeros. So we need a translator. And that's where this tiny but super crucial component comes in. It's called an analog to digital converter, or ADC for short. Okay, part 2, the digital brain. So quick recap. The sensor grabbed the data, the ADC translated it into digital ones and zeros. So where does that info go now? Well, it heads straight to the device's brain. This is the computational module where all the thinking actually happens. This little thing is the absolute core of the device. It takes all that data coming in from the sensors, and it runs it through some logic that a human programmed into it. Something simple like, hey, is the temperature below 70 degrees? And based on the answer, it decides what to do next. It's basically a whole tiny computer on a single chip. Now, here's the thing. Not all these digital brains are created equal. For most simple IoT gadgets, you're going to find a microcontroller, or an MCU. Think of an MCU as a specialist. It's a complete computer system on one tiny, efficient chip that's designed to do one specific job, and do it really, really well without guzzling a lot of power. That's pretty different from a microprocessor, or MPU, which is more like the general-purpose brain you'd find in your laptop. And this gives you a great idea of the kind of brains that are out there. You've got stuff like Arduino, which is this awesome open source platform that's great for hobbyists and for building prototypes. Then you have the Raspberry Pi, which is a legit tiny computer that can run a full operating system like Linux. And then you have chips like the ESP32. These things are amazing. They're low cost, low power, and they have Wi-Fi and Bluetooth built right in, which makes them absolutely perfect for IoT projects. Okay, part 3, from signal to action. So the sensor has sensed. The brain has thought. A decision has been made. What's left? Well, now we have to take that digital decision and turn it back into a real physical action out in the real world. And that is the job of an actuator. It's a great way to think about it. If sensors are the device's senses, then actuators are its muscles. They get that electrical command from the brain and they physically do something. They move a lever, they turn a motor, they flip a switch. They make things happen.
Now, you can find some really powerful actuators out there for heavy industries, stuff that uses fluid or compressed air, but for most of the smart devices in our homes, we're talking about simple electric ones. So back to our thermostat one last time. Its brain decides, hey, it's too cold in here. It zaps an electrical signal to an actuator, which is basically just a fancy switch, and that switch physically turns on the furnace. And just like that, a digital thought becomes a real-world action.
So the IoT building blocks. Let's put this all together and look at the complete picture now. When you combine these three pieces, the sensor, the brain, and the actuator, you get that full, complete loop that really defines what a smart device is. And here's our example, all laid out, the whole loop, right here. Step 1, sense. A sensor, like that thermistor, detects the room is cold. Step 2, think. The microcontroller, maybe an ESP32, decides the temperature is below our set point. And step 3, act. An electric actuator gets the command and switches on the furnace. Sense, think, act. It's this continuous cycle that takes a dumb thermostat and makes it a smart, responsive device. Yeah, as this quote says, they work together to collect and transmit data, back and forth. You can really think of this cycle as the fundamental heartbeat of the entire Internet of Things. It's that two-way bridge, allowing the physical world to talk to the digital world, and then, crucially, allowing the digital world to reach back out and change the physical world. It's a really simple concept, but the implications are just huge. So that leads to a fun question. Now that you know the basic building blocks, what everyday thing would you make smart? I mean, think about it. Your coffee maker could know when you wake up. Your garden could know when the soil is dry. This simple sense, think, act loop really has the power to change how we interact with literally everything around us. The only limit, really, is our imagination. Thanks so much for watching.